In this video, I'm going to explain to you the nature of a partial correlation through a residualization procedure. Now, I hope you can gain some insights into the fundamental basis of a partial correlation, which usually is a little bit mysterious and difficult to grasp for most students, and understandably, I struggled to understand the nature of a partial correlation when I was first introduced to it. So in this example, we're trying to estimate the association between ratings of teachers on the basis of 30-second video clips and end-of-semester ratings by students who experienced the teacher for the whole semester. Now, the control variable is physical attractiveness. That's the variable that the researchers are worried is carrying the weight of this effect. The only reason that video clip and end-of-semester ratings are correlated is that the students, or the raters, are really just evaluating the people, the teachers, for their physical attractiveness. So just to remind you what the correlation was, as well as the partial correlation, I had video clip end of semester in the variables box, and physical is the control variable. That's the variable I'm worried is essentially producing this effect. So what we have here is the partial correlation of 0.731, and I'm going to show you another way to get this correlation through the residualization procedure. And what the residualization procedure is going to do is it's going to decontaminate each variable of its effects due to physical attractiveness, or whatever shared variance there is between video clip and physical attractiveness is going to be extricated from the video clip ratings, and the same thing for the end of semester ratings. So how do you do that? You go into Analyze and then Regression, Linear, and you put video clip rating into the dependent box and your control variable, which is physical in this case, in the independence box, and then you want to save the residuals, and I'll save them as standardized residuals. Click Continue and click OK. And what happens is that SPSS runs the regression, and you can see here that there's a standardized coefficient of 0.501 predicting video clip ratings on the basis of physical attractiveness. That's the same thing as the Pearson correlation. Now what SPSS has done is it's calculated the residuals, the leftover variance associated with video clip ratings, extricating physical attractive shared variance. And so I'm going to change that variable's name to video clip resid. I'm going to delete that because it ends up showing up in the results. And I'm going to do the same thing for end of semester ratings. I'm going to get residuals of end of semester ratings that are left free from the influence of physical attractiveness. So I'm going to go into Analyze, Regression, Linear, and this time here I'm going to throw out video clip and put end of semester into the dependent box and click OK. And again, here's that relationship, the Pearson correlation. It's a standardized beta weight in this case, 0.32, and here are the residuals, the end of semester ratings that have been decontaminated of their association with physical attractiveness. So here I'm going to rename that end semester resid. Yep, end of semester resid and video clip resid. Now, what do you think is going to happen if I run a correlation between these two residualized variables? Well, they've been decontaminated of physical attractiveness, and so it should represent the partial correlation, the correlation between video clips ratings and end of semester ratings controlling for the influence of physical attractiveness. That's the partial correlation. So let's actually see that. Correlate, bivariate, video clip residual, end of semester residual, and here is the correlation, 0.731. And that's exactly the same thing as the partial correlation. Video clip and end of semester controlling for physical attractiveness. Now the p-value is 0.007, and that's with 10 degrees of freedom. And I note in the textbook, here we have the n size of 13, which is going to produce degrees of freedom of 12, because it's n minus 2, and that is not accurate in terms of the fact that the degrees of freedom are really 10 for the partial correlation. And that's why the p-value of 0.005 is smaller than the p-value here. So this is the p-value you can trust in the partial correlation with 10 degrees of freedom, because the Pearson correlation is running on the basis of 11 degrees of freedom. and that's not technically accurate because we added the residuals here. One of the benefits of doing the residualization partial correlation is that you can then create a scatter plot with the residualized variables, which you can't do in the partial correlation utility. So you have to use residualization. So if I click on Simple Scatter, Define, and put video clip residual into my x-axis and end of semester into the y-axis, and then click OK, here is the scatter plot depicting the association between the residualized variables. This is basically the partial correlation scatter plot. And I showed that in the textbook. That's how I created that. So that's another advantage of doing the partial correlation through residualization, is that yes, on the one hand, I think it provides an understanding of the nature of the association. It also allows you the opportunity to create a scatter plot if you wanted to. And obviously, you could do a second order, third order, fourth order partial correlation. You just have to keep adding variables to the residualization procedure. So I could just add more and more variables to the predictor box and get the residuals that way, and then create another partial correlation scatter plot on the basis of those residuals. So I hope you appreciate that approach to conducting a partial correlation analysis, both with respect to understanding and then chart creation.